I'm Doug Atkinson here at Solutions Review, and welcome to the Inside Jam Demo Slam. This year we were looking for a way to provide as much information as possible on the technologies in this space and asked the top solutions to send us a short recorded demonstration of their technology. Just as the name implies, the Demo Slam is intended to deliver lots of information quickly. So sit back and enjoy the show.
I'm going to present Reveal through the web environment, but we also support desktop, iOS, and Android as well, all of which you can always get from our website. So when I first come into Reveal, I'm in kind of like my home section here where I have all the dashboards that I'm working on. I have all my favorite dashboards, all my recents, and then we provide you samples out of the box as well here to take a look at. And through this top navigation here is where I have all my different teams that I can collaborate on. And with Reveal, when you log in with your Google or your Microsoft corporate account, we automatically create an organization for you out of the box. And as your team members and coworkers log into Reveal as well, they're automatically added to this organization. So it's a great starting point for that central place of truth that we were talking about in the deck, where you can have certain permissions for users and you can have your true data administrators be your owners that are really guiding the data that your company is seeing as a whole. And then from there, you have your other different teams that you can then break down permissions and invite different users to. So as a marketing group, we might want to see some different details of data rather than having that at the organization. So that's where you can collaborate with your team there. I did create this one little sample that I was gonna kind of work off for this demo here, where you can see that some of the different visualizations that we have in Reveal present here, as well as I'm utilizing one of our top level filters here too. So within Reveal, I have interactions at the dashboard level for my tooltips. I can expand different charts. I can change charts right from here as a viewer. So I can show you that area chart that Jason was talking about. I can look at the data behind my charts. I can switch back to the original, and then we have a number of built-in statistical functions as well. So I can perform forecasting, linear regression, and outlier detection right within 2 clicks of Reveal here. And what I'm going to do is I'm just going to walk you through kind of like recreating at least some of the visualizations in that dashboard there. So if I come up here to add dashboard up at the top, I'm then prompted to select my data source. So we select, I think, about 20 out of the box data sources now. Each month we add more and more, so we're trying to release every 4 to 6 weeks with new both chart types, features, and data sources. So for the purpose of this, though, I am just going to use a sample file that I have on my OneDrive. And what Reveal does is it now prompts me with all the different sheets that I have within my Excel file here. I can preview them, but I'm just going to select this sales one and select data or pull it in. And over here on the left-hand side is where all of my fields populate for the given source that I selected. The settings for each of my chart types will be right here. So for each different chart type, you have different settings. And here's where I can either click and pull over my data or very easily drag and drop. So if I wanted to recreate that line chart we were looking at, I'll pull over date, new sales, and I think I had forecast here. And then right up here, I'm just going to change that to a line chart, change it from year to month. And then I'm going to change the title to new sales versus forecast. And just like that, I have my first chart type here. And you can see that the settings within this chart are different than the ones that we had for the pivot table. So once I'm happy with how this looks, I'm just going to hit the check up here. And what I'm going to do is I'm going to add that dashboard level filter here. So I'm going to come here and hit date filter. I could have a category up here. So if I wanted to pull up territory, I could pull territory up as a filter to the top. And I'm just going to hit connect, and Reveal recognizes the date source that I'm using, and I'll hit create filter. I'm going to come up here and just change this to last 365 days, and then you can see my data change. I'm actually just going to duplicate this now here and go into edit mode. And I'm going to now change this to a pie chart. So I'm going to remove these fields, and I'm going to switch this to a pie chart. And you can see here that the boxes changed in the data section. So what we're doing is we're letting you know exactly what you need in order to create this chart type. So I need a label and a value, which is different from if I was creating like a combo chart. I need a label and something for chart 1 and chart 2. So if I just come back here to pie chart, I'm going to do just new sales by territory. And I'm actually going to add a drill down to that. So I'll pull over, I think I have a product field, and we'll do new sales by territory. And then once I'm happy with that, I'll hit the check up here again. And then I already have my second chart here. So what we have on by default is an auto layout. So as I keep adding more, the charts will be the same size and keep building from there. Or the second that I start rearranging and resizing in Reveal, the auto layout will go off and I can change and move my charts around as I please. And then what I'm going to do is just come up here to add a new chart type. So what I could do is I could pull in data from another source if I wanted to. I am just going to stick with the same one that we pin up here to the top for you. And I'm going to create a KPI versus target. So I need a date, I need a value, and then I need my target. So then once I have everything needed for that chart, you can see that it populates. I can come here, I can change this to be large number formatting. I can look at this either year to date, month to date, however I wish. And I'll just do new sales here. And then, I didn't mean to do that. I'm not going to connect that to the date filter because it already has a date calculation already going on. So it's already taking my month to date versus the previous, or versus the forecast. So I'm just going to hit check there. And then I can just resize this, bring this up here. Doesn't look as great because I don't have that many. And then once I'm happy with the way that my dashboard does look, I would just come up here and hit this check. I would save this to, I can directly save it to a project that I'm on if I have permission, to the organization if I have permission, or just to my home. So I'm just going to save it right here for now for the purpose of this.
Hello, and welcome to the Stardog demo on Data Lake Acceleration. Let's dive in. So why data lake acceleration? What problem are we trying to solve? Well, data lakes provide a lot of capability. We have a horizontal architecture here where you can continue to add different types of data, regardless of the type. But we should recognize that data silos still exist, whether we call it a data warehouse or a data lake, or some of the other new terms from cloud computing. All the signs are still there. We have lots of databases, with lots of tables, columns, and keys. And it can be structured, and many times often semi-structured or unstructured. However, there's an excessive amount of time spent wrestling data problems, leading to new terms called data wrangling. Quite often, we're still manually coding different components like ETL jobs or pipelines, data quality algorithms. And the challenge to find relevant data to elevate up into high-value information remains difficult. And that means it's difficult for any business to undertake a complex analytic or advanced analytic project. So fundamentally, we want to ask ourselves, can we speed up the time to value of our data lake, creating this high-value connected data along the way, and realizing these value propositions? Now, of course, the answer is yes. And we're going to look at how we can combine a knowledge graph in a data lake which many folks will call a data fabric architecture, to solve this area. Now, there's a lot of different things to talk about with respect to a data fabric architecture, but we're going to focus on just one important aspect today, and that is the data lake along the bottom there, where we have a lot of different types of data, and it elevates up into this semantic layer that connects it, provides meaning, contextualizes it with additional information, and empowers those consumers, whether they're data scientists, apps, APIs, or so on. So if we zoom into that elevation of the data, we see this multi-step process on the left. And we start with those different data sources, and we can start to co-locate the data within the data lake. But co-locating the data does not mean the data has been integrated or unified. And there's a multi-step process that typically results in data being copied, data marts or views being produced, often via code that has to be written that manually joins, fuses, or otherwise combines the data, until ultimately the analysts, the data scientists, the consumers, the applications, they can finally consume it. So we want to take advantage of the data lake technology. We just want to accelerate the connectivity of the data and the insights so that we're spending less time building notebooks that manually combine or integrate data, but instead focusing on the value side of the business and what does that data mean? How does it relate to other particular data within my business? When combined into highly connected information, how can I take advantage of this and consume it to the stakeholders that need it? So let's switch over and take a look at what this looks like. So here I've got a test environment in Microsoft Azure Databricks. And Databricks provides a lot of capability for us. We've got a number of databases here with different tables. I happen to be in this default database, and we're looking at a couple different tables, but let's just take a look at one to get our bearing. And so this one happens to be some user usage data. And thanks to Databricks, we can see the schema and some sample data. Now, this is probably not how a large-scale business would look at it. They'd probably have a notebook that would have some further definition, maybe a data dictionary or other tools for understanding the individual source schema, and then other kind of notebooks and things for dealing with it, which is all to the well and to the good. We have a lot of capability that when looking at a particular piece of data lets us understand it. But we want to start to combine this across tables, across databases, and connect it where the underlying source systems may not have coordinated their column names. They may not have deconflicted or disambiguated elements. They may not have reusable keys, like they could just have incremental integers. And so these are the types of problems that, while seemingly benign when looking at a particular table in isolation, compound and drive that problem space up the time it takes, the tools that you need. And that's the area that we're going to look at today to accelerate. So to do so, I'm going to switch over to Stardog Studio, where I've got a local Stardog running. And from here in the data tab, I see my list of data sources where Stardog enables the virtual graph capability to virtualize an existing resource, meaning Stardog does not require me to move the data. I can leave it in the Databricks or MySQL or whatever the source system is. And in fact, this looks like a standard JDBC set of connection parameters. I've got all the usual fields there. You can see that Stardog supports a whole different set of data source types. I can create connection pools. I can list the different schemas I'm going to connect to. And the data source is used by the virtual graphs that have the mapping that describe how that particular set of data gets turned into a graph. So this is up in the virtual graphs tab. I'm still on my local host here. But you'll notice that this pane here is empty. And to configure the virtual graph, I have some additional options, tables I want to include or exclude. In this case, I'm going to go for everything, and we're going to use this regenerate mappings to automatically generate our virtual graph mappings, meaning I'd like Stardog to inspect the metadata it can find and show me what that would look like in a graph. Now all of this can then be further taken advantage of in additional tools. So if I switch over to Tableau, I can see here that I basically have all the same information. I got my device model, I got my count of monthly minutes, and every one of the types that appeared within the data, as well as certain attributes, get promoted up into the business intelligence layer. And Stardog supports a few different ways to do this. We can create some stored queries where the name of the stored query becomes the table name, and the result variables from that query turn into the columns, and that would then be a table that was visible up here. You can see here report 1 is an example of that. Additionally, there is an auto-generated set of mappings that, given different classes, will generate a SQL mapping. And then that mapping can also be hand modified. So if there are particular aspects of the model that you want some columns that are optional, or fix some data types, or make things just a little bit better for Tableau or the business intelligence layer, you can also make those adjustments. So we've gone end to end from a few disjoint pieces of data hanging out in a data lake. We've discovered them, joined them together, inspected them very quickly within Stardog Studio, and then jumped over here to Tableau to elevate this up for some of the business users. And that concludes our demonstration today on data lake acceleration. Thank you.
Hi, I'm Chris from Tellius. In this video, I'll give you a demonstration of the Tellius AI-driven analytics platform. With Tellius, organizations of all sizes are able to get faster answers from their business data by automating complex analysis with machine learning. We enable anyone to ask questions using natural language, simplifying the data analytics workflow with a unified approach to business intelligence and data science. As a result, organizations can do more than just monitor operational metrics. They can uncover the reasons why performance has changed and learn how to improve business outcomes faster and easier than ever. This reduces the time needed for data analysis from days to minutes and eliminates analytics backlog. Our mission is to empower everyday people to get the answers they need without requiring technical skill. Today, I'm going to show you an in-depth demonstration of how you can do just that. Let's see Tellius in action. Tellius is deployable really anywhere in the cloud, on-prem, or in the hybrid cloud. It's accessible via a web browser, and you can see our left menu bar where you can search, ask what is going on. You can explore, so you can look at things that you've shared or have been shared with you. You can discover, find out why things are changing, and then you can make predictions to understand how you can impact value in the future. So we'll get right into it. We're going to be looking at an e-commerce data set here today. Think like an Amazon or an eBay. So we'll type in first, show me revenue by state. When I type that in, Tellius is going to look at what I asked and understand the appropriate visualization to show to me. So let's refine this a little further. Again, this is about data exploration. So we'll type in 4 headphones after our question. Tellius is going to pick that up and immediately show me the appropriate visualization for the question that I asked. So let's dive in a little bit more on headphones. Let's say, what are the top 3 sources generating the most revenue for headphones? Tellius will look at what we asked, and again, it's going to show us the appropriate visualization with the appropriate filters and the appropriate metrics that we asked about. We can see here, paid search is actually dominating our headphone revenue. So let's switch it up a little bit. Let's do a more complicated question. Let's say, what is the revenue growth for social compared to email quarterly in the South? Again, this is a natural language question that Tellius is going to analyze and then make calculations on the fly and show us the appropriate visualization for the question that we asked. I think this is really great. So let's say we want to share this with a colleague and they want to understand, okay, I see your question, what exactly is this data? Well, we can just click on the query inspector and you can see this is a very traceable type of system. We show you exactly what we analyzed, exactly by what dimensions and what metrics that we're looking at. So let's look at something over time. Let's say, what is going on with my revenue quarterly? Tellius is going to, again, look at what we asked and show us the appropriate visualization. We can see here, revenue was pretty flat for about 5 or 6 quarters, and then it went up and down significantly. Tellius is going to automatically highlight where there are statistically significant anomalies and prompt us to understand why those are changing. So we'll just hit check reasons here, and we'll show you the first of our 3 insights. This is a trend driver insight. So in this case, we're looking at what drove the change in revenue between first quarter and second quarter when the exit page was about. We can see a very significant change, about $3 million over that time period. So we can see top change contributors. So what are the major dimensions with attributes that are driving that change? And we can also see why things are changing, maybe some other metrics that are changing at the same time. So we'll dive into those dimensions. What exactly is changing for revenue? We can see that source, exit page, product category all have some attributes that are really driving a significant change. Let's go back to the top reasons for change. These are other KPIs or metrics that are changing in conjunction with revenue. So we can see that our number one change is actually average session duration for the states of Maryland, Virginia, Louisiana. This type of ad hoc drill down analysis is really great when you're trying to find out exactly why something is happening. So we'll go back to what actually happened. We'll look at the different dimensions. Again, we're looking at source, and we're going to actually dive into source, and we can see for source, what are some contributors to that drop? So we're looking at time of day and region. We can even dive down, so we go down from revenue to source to region. We can look at state, for example. So let's say I want to look at source in detail. So I'll compare social versus paid search. This is our second insight. This is a class comparison insight. Again, we're looking at, for that time period, how did paid search compare to social? We can see that social actually had a 4.6 million more of revenue over this time period. And those changes were driven by high income individuals, car electronics, and individuals over the age of 60. We can look at each of these different dimensions and see an analysis over where revenue is changing and what the individual attributes are changing within those dimensions. And we can do the same type of drill down that we did looking at high income. Well, let's look at age or payment type or product category for those high income individuals. Now let's say instead of doing this type of drill down, I want to understand a segment that may be the right one to target. So we're going to look at our third type of insight, which is called a segmentation insight. On the left, you can see we've run actually a machine learning model to understand what are the top drivers for this individual customer lifetime high value metric. We can see that's income, channel type, and time per session. On the right, we can see our top segments, so very specific, unique, individual segments where high value customer tag is more likely to occur. So in this case, we can see that customer lifetime high value is 4.8 times or 4.7 times to be more likely to occur based upon these individual criteria around income, channel type, how often they spend on our website, their age, etc. If I want to iterate on this and remove income, I can do that really easily. I just go to edit, I find what I want to remove or include, and I can drag that into include or exclude, and then hit replace or create new, iterating very quickly on our insights. So we've understood our three different insights, why things have happened. Let's look into how we can maybe predict how things will happen and maybe affect how our business will perform in the future. So I go to our predict functionality. We have two different methods here, AutoML, which is as simple as just choosing one variable that you want to predict, and then point and click, which we'll go into in a second. So this is AutoML. All we do here is we navigate to AutoML, and then we choose the column that we'd like to predict. So in this case, e-commerce, we've got a customer health score. Let's predict customer health. So I just choose that variable, I name my model, and I hit predict. Tellius will automatically figure out the type of machine learning model that's best to run, and it'll run several of those to try to get to a best model for you. So we'll go back to point and click before we show you some results. So we'll just go predict and then point and click. We've actually got 5 different types of groupings of machine learning models. So we'll look at classification. We're going to look at that same customer health score and try to predict, are they at risk or are they normal? So here, point and click gives you a little bit more control and power. This is maybe for a more technical user. So again, we'll just select our target variable. We'll select the data set that we want to train. So customer health, we're just going to train a 20% sample data set. We'll choose a number of n-folds, and then we'll actually choose the features and how we want to handle each feature, from the data type to how we want to handle null values to how we're going to do transformation on features for actually machine learning. Once we do that, we just hit next. And here are all of our different types of classification machine learning models. So we select the types of models that we want to run, and we can go through and change the parameters for each of those types of models. So let's look at some output from one of these. We can see here, this is only one type of model. So on our leaderboard, we've only got one, but you could also see multiple here. We can look at performance. So for all kinds of different performance metrics, how is this model performing? This one's pretty good. We can see some other metrics down here at the bottom, the confusion matrix, also our ROC curve, a visual representation of the confusion matrix. And then finally, explainability. Within Tellius, we think it's truly important to be explainable. From that query inspector we showed you earlier to this. We're showing you for each prediction that we make, what are the factors that drove us to make that prediction based upon our machine learning model. One of the greatest things about Tellius is that you can integrate the output of predictive models into VisPaths. Here, we've created a VisPath that allows anyone to easily use the model that we just created, which in this case predicts if customers will be of high value to our organization. This can be shared with anyone inside or outside of the Tellius platform. I hope you learned a lot from watching this demo. I'd like to invite you to learn more from our website, where you can start your free trial today. Thanks for watching, and have a great day.
My name is Sri Raghavan. I have been in the analytics profession for over 20 years and have worked with hundreds of companies to deliver analytics implementations across many verticals and use cases. And in the last couple of years, I've been traveling the world to train thousands of customers on Teradata's Vantage Analytics platform. Today, I'm here to show you that power of Vantage. Okay, what is Vantage? Vantage is an enterprise-grade software which brings together the data warehouse, the data lakes, and analytics together. It's available on the public cloud, the private cloud, as well as on premises and in a hybrid environment. Vantage is built in world-class Teradata database technology, brings together multiple genres of analytics together, such as your machine learning, statistics, graph. And here's the deal. All of these different analytics functions and all of these data that are available across multiple sources can be executed in SQL, in Python, in R, as well as analytic visualizations can be delivered through components like Vantage Analyst and App Center. The best part of Vantage is that it is available across a wide constituency of people in the organization who want to be data-driven. Your data scientists, your business analysts, the lines of business managers, anybody who wants to be data-driven can use Vantage. And all of these insights can be operationalized in the platform. Not only are you able to deliver these insights on all of the data across these different analytics techniques, but they can also be operationalized in the same platform. This is what Vantage is. Okay, but now that I've told you what Vantage is, let's actually take a specific use case and see what we can do with Vantage. So here's an example. Let me set the context for you a little bit. Here's is an example of a retailer who wants to understand customer churn. And the way they're defining customer churn is that there are members in their organization who cancel their membership. Understandably, the retailer wants to know why people are canceling the membership. Because if they can know why, and if they can predict who is likely to cancel their membership, they can take certain bits of corrective action. So here's an example of a path analysis application. This is a visualization, it's a Sankey visualization, and there are different sets of activities which contribute towards membership cancellation. So here's one example, right? So it seems like in this case, there are a lot of people who seem to be making a complaint call before they cancel their membership. So what does this tell the retailer? It tells the retailer that clearly there seems to be something going on with the complaints. So they look at this path and they say, okay, let's figure out what's happening with the complaints. So the next thing they do is they go and they want to understand the nature of these complaints. So what they go into is a sentiment analytics application. They look at it and say, look, it seems like a lot of people seem to be confused with our policies. They seem to be sick. They seem to think that a lot of our policies, a lot of our what we do for them is silly, and they're confused, they're tired, it's inconsistent, it's expensive, it's inappropriate. There's a lot of confusion. And you know, to that point, the word confused comes up big in the word cloud. Now, what's the point? Now, they're able to see a path. You saw that in the path. They see sentiments that are being expressed that are very negative. And then they say, look, I seem to understand these things that are happening. But what I still don't know is how can I predict that somebody is actually going to not be a customer any longer? So here, what they do is they want to model it. They want to, you can model customer behavior in many different ways. So here, for instance, is an example of a machine learning model. Forget the guts of the machine learning model for a quick second. But what they want to understand is what's the risk that a customer is going to churn based on all the different activities that have already taken place from the path analysis, from the sentiments that have been extracted. Let's actually try to model behavior. The reason why you do that, and these screens where you can actually pick and choose the different models that you have. So here, for instance, I pick one type of machine learning model, but there are many other different types of models that are available. You can actually run these models, and then you can see how well the model is performed, right? Because whenever you have created this sort of predictive model, you want to see, does my predictive model make sense? And here it looks like your model has got a high rate of precision, 92% of the time. And that's a fantastic precision rate. What is my point here? My point here is that we used Vantage, native applications in Vantage, without any coding whatsoever, pulled it up from screens to be able to understand how customers behave in terms of path analysis, what they are talking about you in terms of sentiment extraction, and how you can predict the likelihood that they're not going to be a churner or are going to be a churner with this machine learning model on many different kinds of data that are available. But before we get into some of the differentiators, let me show you one more thing, right? Sometimes analysts say, well, look, all these screens are fantastic, but I'd actually like to see the code. No problem. So here is an example of how you would run the same retail churn example that I said before with membership purchase and membership cancellation using code. So here's an example of SQL code where I select that function NPAT, the path analysis, directly from Vantage. And then I use the same sentiment extractor function also from Vantage. I just simply call it directly from Vantage. I run sentiments to get the positive versus a negative on each one of the sentiments that have been expressed and put it in a word cloud. And then here's an example of another kind of model. I showed you Decision Forest, but here, for instance, is a model called XGBoost, where I run it directly to predict the likelihood that someone has churned. So here is the prediction. This customer 194020 is predicted churn, right? And this is how you operationalize. Now, what's the advantage of doing it all in Vantage? Number one, when we do it across path analysis and sentiment extraction modeling, different kinds of data are brought into the picture. Your structured data, your semi-structured data in terms of web logs and online activity, and then your completely unstructured data. All of those things are brought directly in Vantage. One fell swoop in one platform, number one. Number two, did you see all these different analytics techniques and screens that I showed you? These are machine learning models, these are sentiment extractors, these are path analytic applications. If you go outside of Vantage, you have to have 3 separate solutions to bring them with 3 different screens and 3 different user interfaces meant for 3 different personas in 3 different solutions that you have to pay for. None of that in Vantage. All of those things are brought into one platform in Vantage. And that's a huge differentiator. All of these activities, from insights delivery to operationalize on all your data across multiple personas, happens in Vantage, and that's a core differentiator.
Hi, this is Paul Scott Murphy from WANdisco. I'm very pleased to be able to show you today a demonstration of brand new capabilities in Live Data Migrator to migrate actively changing Hadoop content from on-premises clusters, regardless of what format they're in, directly into Databricks using the Delta Lake format, so that not only can you migrate changing data at any scale, but get immediate access to it in the form that makes it most usable in the Databricks environment. To demonstrate, my demonstration platform consists of an on-premises Hadoop cluster first of all, in which I've got this REPL1 directory with a collection of content within it. We're going to use Live Data Migrator to migrate that content into an ADLS Gen 2 storage account and specifically to this PSM container within it, currently empty of any data. We'll then access that data and use it from my Databricks cluster. In this case, I've got a notebook open, and I can view the data in my environment, showing me that I've got a collection of databases, in particular this retail database in which there are currently no tables. So the process begins with the WANdisco user interface. I'll log into that with my credentials. Having just installed the product, it gives me visibility as I would see immediately after installation. So the first step is to define a target file system to tell Live Data Migrator where it can deliver data to the cloud. I need to give that a name. Let's call it PSM Gen 2. The storage type is ADLS Gen 2. I need to specify the type of credentials that I'll provide. In my case, I want to use service principals. We choose the account name for my storage, PSM Thursday Storage, and the container name within it, PSM Container. I need to provide the details of my credentials, my client ID, my secret, and the endpoint for OAuth communication. Let's do that now. Clicking Save lets Live Data Migrator validate that it can talk successfully to that target storage account, which it's done, and shows me the storage now in the view of targets and sources that I have access to. Migrating data then is a very simple matter. I create a migration, I give it a name, let's call it REPL1. It chooses the source, my automatically discovered source Hadoop file system, my target being the PSM Gen 2 storage target I created a moment ago, and then we choose where the content reside in my Hadoop cluster that I want to make available in my target storage. Additionally, if I wanted to, I can add exclusions to avoid any content I don't want to migrate. I choose what to do with any content that reside already in my target. It's empty, so we'll just overwrite. I'll start that migration automatically and leave in place the option to perform a live migration, which gives me the ability to migrate any changes without needing to reschedule, rescan, or issue any further commands against the environment, keeping my target entirely consistent with the data as it's changing in the source. So I create that migration. We see that in the running state. It doesn't take long to migrate the data. We see the bandwidth graph updating there to demonstrate that it's sent information across the network, and I can return to my storage account, refresh the view of my container, and we see now it contains that REPL1 directory with all of the same data and the structure within it. Returning to my Databricks notebook, here I've already mounted that. We can get a listing of the Mount ADLS Gen 2 REPL1 path, and once again see all of the content visible to my Databricks environment. What we don't have though is any currently replicated or migrated version of the Hive metadata from my on-premises environment. So looking at the terminal window here, let's look at that retail database. Showing the tables within it shows that it's currently empty of any tables. To migrate the changes that I perform in Hive in my Hadoop cluster, we need to create a Hive target and a Hive migration rule in Live Data Migrator. To create a target, we go in here and add a Hive agent. I'll give it a name. I'm going to call it Databricks Delta Lake. Choose the agent type. In my case, I'm migrating my Hive metadata into the Databricks runtime. And then I need to provide the details of how I communicate with the Databricks endpoints. In particular, the JDBC server hostname and port, the JDBC HTTP path, which uniquely identifies the cluster to which I'm migrating data, and my credentials in the form of an access token. Now, the unique thing that we've added with this capability in Live Data Migrator is this automatic conversion to the Delta Lake format. So I'll choose that now, reference the mount point that I'm using from my Databricks environment, the file system to which my data are being migrated, and then I can choose whether I want to override the location in which my Delta Lake content will be written. In my case, I want to do it under that same mounted Gen 2 storage account, and we'll put the data into a location that I'll just call Delta Tables. There we are. So I'll create that Hive agent now. And once again, Live Data Migrator validates that it can communicate successfully with the endpoint, and that's all green and healthy. To perform the migration of my Hive metadata, which is currently not happening, again, if I return to my data, we can see there's no tables within that retail database. But I can initiate the creation of those tables by putting in place a Hive migration. Let's give it a name. We'll call it Retail. Choose my source, being the automatically detected Hive environment on premises, the target being the Databricks Delta Lake, a configuration I created a moment ago. And here again, we can be selective about what metadata we want to migrate. In my case, I want to migrate any tables that exist under the retail database. And I'll tell that to start as soon as I've created it. So clicking on Create shows me the representation of that Hive migration and that the status is live. So any pre-existing content has been moved. We can view the details around the migration there, or just go back to the dashboard to see progress as we perform changes in the Hadoop cluster to initiate the migration of those changes into my Databricks environment. So let's do exactly that now. We don't have any tables within my database, but we can create one. So if I return to the Beeline view and issue a command to create a table called customers, we'll specify the location being in the REPL1 directory, and you'll note here that I'm doing it in the Parquet format. So unlike Delta Lake, a different format on premises. So I've created that table now in my Hadoop cluster, and we can show the tables. There it is, the customers table, and again, the schema associated with that. If I return to my Databricks environment and just refresh the view of that retail database, we can see that it also has a representation now of the customers database because the Hive migration is in effect. We can see the very same schema with all of the data types and names around the columns, and of course that there is no data associated with this table. It doesn't contain anything yet. But because the table is there, we can be issuing queries against it. Just returning to my notebook, we can, for example, describe the table. And again, I see the very same schema, but note here that the location for the table data is within that Delta Tables directory that I specified, and then the subset of that being the REPL1 retail customers location, and in particular that the format of the table is the Delta Lake format. If I issue a query against it, perhaps to summarize a view of customer count by state, once again we can see that the query returns no results. But of course we have live migration in effect. So not only is my metadata being migrated, but the data associated with that REPL1 directory being migrated as soon as it changes into my ADLS Gen 2 storage, making it accessible for use from the Databricks environment. So let's do that now. I'm going to insert some data into that customers table, loading in a collection of customer data for the state of California. That's going to execute as a job in my Hadoop environment, interacting only with the Hadoop file system and the Hive metadata for the table itself, for summary information, statistics, and other details. That job will take a few seconds to run in the Hadoop cluster. It's beginning now, and we can see the progress around the job. It will take maybe another 5 or so seconds to complete. If I return to the view in the WANdisco user interface, once that job has completed, we'll see the bandwidth graph being updated as the data associated with that ingest are being transferred into the target storage in my Gen 2 account in Azure. So the job's completed on premises. Live Data Migrator has immediately been given visibility of those changes and is migrating the data into my Gen 2 storage account. But in addition to that, because we've chosen to automatically convert that table content into the final Delta Lake format, I can issue a query directly against my Delta Lake table. Running that query now against the retail customers table shows me that it's got visibility in the Delta Lake format of all of those customer details for the state of California. Again, I can issue any type of update or change to the table on premises. Perhaps let's ingest some additional data for the state of New York. Return to the WANdisco view once more to see not only is the bandwidth graph showing me what occurred when I updated the California customer data a moment ago, but once that job is complete, adding the ingest of customer data for the state of New York, we'll see that represented in the bandwidth graph as well. Without me needing to issue any rescheduling or rescanning of my source data or my metadata, WANdisco Live Data Migrator is performing the migration live. So as soon as the change occurs on premises, the change occurs in the target cloud environment as well. There we see the bandwidth being used for the customers of the state of California. And again, if I return to Databricks and reissue the query there, we get back the results not just for California, but all of my customer data for the state of New York as well. So that's the demonstration of this brand new capability in Live Data Migrator to actively migrate changing data from a Hadoop environment on premises, including Hive data and Hive metadata, making that immediately available in my chosen cloud target environment, in this case Databricks, using the Delta Lake format without me needing to do any extra work. So I strongly encourage you to take a look for yourself at Live Data Migrator. It's an entirely self-service product, installs in a moment. You configure it in just the way I've shown you here today, and you can try this for yourself against your own Hadoop clusters, targeting Azure Databricks, targeting Databricks and other cloud environments as well. Thank you very much for watching.
So there you have it, a demo slam. We hope you found this unique virtual showcase of industry solutions beneficial. We tried to compress a lot of information into a small amount of time. That's what the Inside Jam is all about. We appreciate you sticking around till the end. Thanks for watching.